Oh, right, more changes. I want to make a quick video because I want to get this sort of out of the way. Philip mentioned yesterday that the images are, have quite a large overhead. So if we look at this issue, it hasn't been merged yet, but it will be done by the time this video gets posted. I just need Philip to review it to make sure that on all of his things it's stable. But essentially, Philip was saying to me, he's like, hey man, the images are quite slow, we need to cache them. And so I've added something in yesterday. So this is through the issue. I've made some changes and I just want to make a quick video sort of go through how you update changes again, because I did this in the last video where I was talking about TUM fonts and it's the exact same principle. I'm not going to be able to do it because the pull request hasn't been merged yet, so I don't actually have the final commits, because I'm also going to have to rebase the code so that it's nice and pretty for you guys. But I'll just quickly explain how you would go about it, and then quickly just want to show the differences because the demo code is going to be slightly different, and I want just to sort of make it a bit clearer how the API works, just so it doesn't confuse you guys, because some of these APIs might not be super intuitive to you. So quickly, I guess not looking at this first, but if we go to the repository again, how you would update your changes is that you need to use cherry pick essentially. When I go ahead and create the final commits, if we look at go back to like the commits that I use for the fonts, because they'll be the same. I'll split the changes into sort of the changes that go for the back-end libraries and then also the changes that happen for main. So I split this into two separate commits because if you're merging the changes to main, you'll probably get merge conflicts, which is not pretty good for you guys, but the changes to the back-end shouldn't have any conflicts for you unless you've gone and modified the back-end libraries. But the whole idea is that if we go here and we look at the commits, so when I went to do the adjustable fonts, this was the fix that I had, but essentially the pull request that I did, or the changes, was these two commits. Now this is the one where I added example code to the main, so this is the one that if you were to merge it, it would probably give you merge conflicts. But this one here this is just the changes to the back-end library. And so if we go into this commit itself, we will see that it's changed 4 files, and these files are just back end, so this shouldn't give you any clashes. Now, in the pull request that I'm doing for this, which I think is referenced, what's happening here? Put you back in here. Pull request. There's at the moment it's super mixed, and essentially you'll be able to see the changes for the back end, and in the end I should have created 2 nice commits, which I can't show you yet, but they will be there, and you'll see it. You just want to pull the one that has the changes to the back end, because in here files changed. At the moment it'll be main and draw.h and .c, and you'll just want to pull the changes to just the h, draw h and draw c, so it won't clash. But okay, so that's how you would do it, using git cherry pick, and then you want to pull the commit ID. So in the case of the fonts, you would have used git cherry pick and then this commit ID. So if you go into the commit, you can also find the full commit ID here. So example's sake, if I was to go into here and I was to go to main, to your master, sorry, you would go git cherry pick, and then you would put in that command, that commit, hit enter, and it will pull and merge that one commit's changes to your master's branch. So as you can imagine, this is pulling the changes to the back-end libraries done in this. So hopefully that's pretty easy for everyone to understand. After doing the Git tutorial, you should sort of understand how Git cherry pick works. But now the second thing I just wanted to quickly go about is the API, as this has changed a little bit. Well, it hasn't changed, I've expanded it, and I just want to sort of say to you guys, if you looked at the original demo code and anyone's sort of gone through it yet, you'll see that there was, to loading images, we used tumDrawImage, where you put in a file name. Now the thing is that this file name, the whole process is that it loads the file, creates the SDL's backend texture every time, and draws this to the screen. And And this is a lot of overhead. And so Philip, especially because his laptop is, let's say, not the fastest laptop in the world, he was having problems. And so we're trying to look at ways that we can squeeze more power out of it. And so we've just sort of cached the images. Well, we've added in a second way of drawing images using the tumDraw loaded image. And so the loaded image is that you'll load the images first in like somewhere, usually in your main or some sort of an init function, and then throughout the rest of your code, you reference these images with a handle and you draw them. Instead of every time just passing in the file name, because that way it's a little overhead intensive, and seeing as a lot of your running this in a VM and you want to do the game later on with images like sprites, I think if you were to do this using the normal call, this tumDrawImage, your overhead would make your game just crawl to a stop, because usually with game development, it's a lot easier to just use images for certain things instead of trying to draw them out of graphic primitives. Now that being said, if we're going to do Space Invaders probably this semester, so lots of things like the little ship or like a bullet, which can just be a box or an ellipse or an ellipse, using graphics primitives is a lot quicker. I mean, like computationally faster. So if you can, and it doesn't look crap, or you want to do it that way, I would recommend using graphics primitives. But if you don't, then the new API, so if I have here, this is the original, this is the current master, so I haven't merged the pull request yet. So this is how it was. Now if we find draw logo, so here's an example in the one in the main, the old main of how I was drawing an image. So I have this logo file name, which is at the top, and it's just the relative path, because the whole thing executes from where the binary is, and the binary is in the /bin. So the relative path to the image is like up a directory here, double dot goes up a directory into resources, and then this is the file name. You can also use absolute paths, but the problem is that if I then go to check out your code and run it on my computer, I don't have the same exact file structure as yours. So please try and use relative paths. Using hard-coded paths in general is kind of bad, but I don't want to implement some sort of a file managing thing on this because it would take too long and I have other things to do. But so essentially this file logo file name here is the relative path to where the file is stored, and I was using this tumDraw scaled image call. Now the scaled images as well, even with the new API, like the extended API, scaling images, as you can just imagine, has an overhead because the hardware has to, or the software / hardware, depending on your system, is having to do these extra operations. So for increasing speed, I would also recommend you, if you want the image to actually be bigger or smaller, go into like an image editing program like GIMP or Photoshop or Paint or whatever it is that you have on your system, and actually scale the image and then save it again onto the system as a scaled image, so that you ideally can just go tumDraw and not use the scaled one. So it doesn't have to do this scaling because it will make it quicker. Now the old API has you loading in the file name and then the X and the Y coordinates. Now this is slightly different. So if we look at, this is the pull request code. I think I need to check it out again. I'm checking out fix cache images. Now if we look at main, it's slightly different now. So we'll go down to our main function. Oh wait, I am there, so stupid me. So if we look at here, so this logo image, now how this works is if I'll close, like nothing really changes, so I don't need to show you the actual execution of the function, but if we open up the GitHub FreeRTOS. Yeah. Now I've added documentation. Oh, it's actually not up there yet. Sorry, because I haven't merged this, but I have a local copy of the documentation that I've generated. So I'll open that. So if we look at the documentation, you'll see now that we have this image handle.t. Now, as you can imagine, as if you went through like the fonts things and all this stuff, like a good way of doing, or a thing I like to do, is you have these handles to reference objects, but I sort of restrict the access that you have to the object by making you use these API calls passing in a handle, because this image handle is actually to protect, I wonder if I have it in here anywhere, a structure called loaded image. Yes, this guy. Struct loaded image. So this is the actual back end structure where I have all the different things that I use to manage the object, and you just have to have this handle, and then all of API, the library functions, use this handle to do certain things. But I actually don't by doing this, it sort of restricts the user, in this case you, from doing things like corrupting the read-write ops of it and stuff, right? So this is the handy bit of having a handle, in that it restricts the user what they can do, because I've only allowed you to do, for instance, load scaled image, load image, load scale image, free loaded image, set, and you can set and get a few things here, but you can't, for instance, set the renderer or set the texture, because this would break certain things. And so I've restricted what you can do from sort of like the front end, if that makes sense. But essentially, so we have this handle, and then we have, as I said, there's these couple of functions. Most importantly, for instance, here is load image. You can still load a scaled image. I mean, this might be useful for you, or you can set the image's scale. But scaling, as I said, anything that's not 1.0, meaning there has to be some sort of scaling done, will incur an overhead. Now, you'll have to test it with it. Maybe the overhead for you is nothing. Like I'm on my native Linux system, if I run scaled images, I have 0 to no overhead impact, because I have native OpenGL support, because I'm running directly on graphics hardware and stuff, and it's fine for me. But if you're running on a virtual machine on top of some sort of non-native environment that doesn't have OpenGL support, you could get some like really heavy overheads. So now that we've got these functions here. If we look here, I have at the top, I've created a handle for it here. I've actually, in this example, I've just created 2 because I wanted to make sure that if I delete the image, it doesn't run. So we have this logo image and logo image 2, which I have created as image handles here, right? So if we look here, we're drawing it here, but we have to, we load the image. Here I'm loading it as a scaled image with a scale factor of 0.3, meaning it will draw at 30% of the size. And then this one here is just creating a second image of the same file, but obviously this time it's unscaled. So essentially, this just calls this with a scaling factor of 1. And then here I'm deleting, so I was testing that when I've deleted this, and then later on I'll try and draw it, that it doesn't crash. It actually just spits you out some errors saying, hey, well, this doesn't exist and stuff. So now if we look at where we are actually drawing this, you have to load this, and so my recommendation to you would be like, get all the images you need. In your main or something, create sort of like a load image function that loads all of the images and keeps track of all your handles to the images, and then later on in your code, you can just draw them. I mean, you don't really need to worry about freeing the images. I mean, I did this just to check with it. You can delete the images, and that will make the handle null, and you can't use it anymore, and it will delete them. It'll free up the memory. But I mean, for most of the time, you'll have sort of like these sprites that you load into memory, and then you just use them all throughout the game. So you don't really have to ever worry about freeing. But just in case you did, it's there. So we'll look now at where I was using this to draw it. So I've sort of replaced the original call to get image size with a few different ones. We now have get loaded image size, which works on the same idea. You have like an image handle. Instead of a file name, you give it the handle, and you pass it a pointer to a width and a height variable, integers, that will then be filled or populated with the width and the height. Or similarly, you can just call these two and pass it the handle, and they will actually return the integer of the width or the height. And if you just click on these, it should document it for you how it works, right? So here you can see that I've used this one where I'm just getting the height. Similarly here, I'm getting the width. Now I don't have any error checking here because I was just doing it really quickly. And this code will probably be different once I've committed it, because this code is just to check that everything works, but it's by no means actually, it throws a lot of errors, which it should do, but it's not how you would actually use the code if you were to use these images. But this image here, this logo image was freed So this fails. So this call here actually doesn't, it returns -1, so it fails, and this error message essentially just gets spammed to the terminal when I run this code. But this guy here, so I'm getting the height, and then this does work, this draw loaded image, and so I have to pass it the handle, and then I pass it the x position. In this sense, I've called it to get the width again, and you pass it the y position, and it just draws it like normal. So the API is very much similar to the other one, the original one. It's very simple, but I just wanted to make sure that everyone knows that this sort of loaded image API is there, and that it's probably important to use it. It's a little more complex to use. You have to have these handles and pass in the handles, but the overhead reduction should be significant, that it actually makes sense or is worthwhile for a lot of people. So that's all I pretty much wanted to say. I hope this works. If you have any questions, especially you'll have to be able to find the commits yourself once they come up, just send Philip or I a message, and yeah. So thank you for your time. Stop recording.